I don't know what is going on there. I've got two versions of that. I don't need that. Pi over 6 would have been 4 square root of 3 over 2, 2 square root of 3. Second square root of 3. That'll help us out. Cool. Yeah. All right. So we have one last question to answer on this one, and that is, what is the speed? Thank you. What is the speed of our particle moving as it moves through the point 2, 3, which is the point that we have highlighted here in purple. And our goal is to find the, oops, sorry, I definitely wrote it in the wrong spot, right here. Our goal is to find the magnitude of this vector. We're at the point 2, 3. Got to find its velocity. Is that velocity actually coming out nice? We'll find out in a second. I feel like I have this velocity vector drawn too nicely, but we'll see what happens. Maybe one of the... Anyway, we got to find the speed. We just have to use the speed formula. Speed is you take the magnitude of the velocity vector. Okay, this is definitely different than what we were doing in one-dimensional particle motion. But it is just following a formula. So we have our v of square root of pi over v of square root of pi over 3, which is where we got the point 2, 3 from. I feel like I didn't draw that vector incorrectly. It should have went to the left about 3.5. So I should have went 1, 2, 3.5. And then it should have went up about 1.75. So that is the correct velocity vector. I only went over 3. All right, cool. All right. So that being said, if you're asked to find the speed, I would first find the velocity vector. That way you have the numbers that you need. And our numbers, for graphing purposes, we were using decimals. But I went back to this point, which had those same two numbers in them. This is the x point, but because we're using sine and cosine, we're just getting repeated values. We're doing the same math for different reasons. So that 3.464 is really 2 square root of 3, and 1.732 is just 1 square root of 3, and that's going to make it a little bit easier to plug into the speed formula, which in the end is just the Pythagorean theorem. This height of that vector is the square root of 3, and this width, or I guess length of that vector, the x component, is 2 square root of 3. So the speed is the magnitude of the velocity, which is the square of the two components of velocity. So that's going to be negative 2 square root of 3, but squared, plus the square root of 3, but squared. So because everything is multiplication there, you can distribute that square. It ends up being the square root of, we've got to square both 2 and square root of 3. So that's going to give us 4 and regular 3, or 12, plus the square root of 3, but squared is 3, which is the square root of 15. In terms of two-dimensional motion, that's what speed is. Speed is a formula that you follow. I would compute the velocity vector first and then plug into speed. I had already done that because we had done that in letter B yesterday, but that's where I got those numbers from. And since we were using sine and cosine, and we were doing things like squaring, I went back to their square root forms rather than using the actual decimal numbers. But 2 square root of 3 is the 3.4 number, and square root of 3 is the 1.732 number. Okay. Questions on that? All right. Okay. So, example 2. Sketch the path of the particle moving along the plane curve given by r of t equals that vector that you see there for t in the interval between 0 and 4. I'm just going to make a quick table down here where I have some space. I'm going to put t in the left column and r of t in the right column. Count from 1 to 4, or from 0 to 4, I guess. The vector that we have, the y-coordinate is just t, so all of our entries over here are going to end in the t value. And we've got some math to do to figure out the x-coordinates. So plugging 0 into a polynomial is easy. That just gives me the number that doesn't have an x or a t next to it. Plugging in 1, actually you do it. Take a second. Plug 1, 2, 3, and 4 into 3 plus 2t minus t squared there. Do your numbers match mine? Zero's right there? Yeah. Okay, cool. So again, we're going to just start with those numbers, 3, 0, 4, 1, 3, 2, back, 0, 3, and negative 5, 4. So our particle is basically, I mean, if you think about what's going on here, the way that this is set up is we've just used t to sort of swap what x and y usually do. Normally, we take x values and plug them into something to get our y values. But because y was t, we plugged, we had those y values and we plugged them in to find our x values. The thing we have is a parabola. But since x and y had kind of swapped roles, we end with a sideways looking parabola. Because these were our x's. I mean, these were what we normally think of as x's. We plugged them in and we got these values, but these weren't our x's, these were our y's. And then we'll draw an arrow on it just to show the direction of travel here, and it is going in one direction. Cool. All right. So we sketched our path. We've got to find v of t and a of t. Those things are really easy to do, especially with polynomials. We just have 2 minus 2t, comma 1, and negative 2, comma 0. Agree? Yeah. Cool. All right. And I think I've done everything they've asked me to do there, right? Find the time t when the horizontal component of the velocity is 0. Describe what happens to the particle at this time. So just some of these are just understanding what the vocab is saying here. The horizontal component is the x component of the vector, and that's what we call the two different pieces. So this is the horizontal component. When is that 0? Well, when is 2 minus 2t equal to 0? When t equals 1. Oops. Yes, t equals 1. That is going to, yeah, t equals 1. Which is the 0.41, which if you take a look at it, this should make sense, especially yesterday when we looked at the Desmos of how the x, I always want to say, I have the wrong word, the x component tracks on the x-axis where your point is. That x component would go over to here and then track the particle as it went to the left. So when one of your components is 0, that's when your particle is changing directions, but specifically in that component's direction. So since we're talking about x, at t equals 1, our particle stops moving to the right and starts moving to the left. Has nothing to do with up, down. It's all about left and right. And sure enough, our particle is doing both. It's moving up the whole time, but at one point it does stop moving to the right and starts moving to the left. So you can kind of get those one-dimensional questions inside of these two-dimensional problems by focusing on a specific component. So at time t equals 1, the particle changed from moving right to left. The question could ask, when is the particle moving right and when is the particle moving left? And again, it's just focusing only on that x component and just solving a one-dimensional problem. It's moving to the right from 0 to 1, and it's moving to the left from 1, in this case, to 4, or from 1 on, depending on how the question is written. I could also ask you the same things about the y. The reason this particle is moving up the whole time is, look at the y component. The y component is positive 1. This particle, if you don't care about its left or right, is moving at a constant speed up 1 unit per unit of time, 1 meter per second, there are no units here, but 1 meter per second, 1 inch per day, whatever the units are. The upward movement is constant, but the left to right movement is what's changing. And that's what that tells us. So, this particle is only moving to the right because its velocity is always positive, or always moving up because its velocity is always positive. And then I think that's what my next question asks. When is the particle moving upward? The whole interval. 0 up, 0 less than or equal to t less than or equal to 4, because v prime, or v of t equals 0. Or greater than 0. And down, never, because v prime of t is never negative. A couple different ways to write that, but that'd be a good answer to that question. Back and make one change up here and call out how I found these things. Just to model good FRQ practice. I thought that in the middle of my answer there. Letter D, I think, is the tricky question. Is the particle speeding up or slowing down at t equals 1? In one-dimensional particle motion, we were able to look at just the sign of the velocity and the sign of the acceleration. And because we were only moving left or right or up or down, if those signs matched, we were speeding up. And if those signs mismatched, we were slowing down, right? In this case, we actually have to look at the function that finds our speed, and we have to decide if that speed is increasing or decreasing. So this is a much more complicated problem. We have to find the function for speed. So speed is the magnitude of velocity, which is the square root of the two components derivative squared. So that's going to be 2 minus 2t. Let me be more specific. It's the velocities squared. So component doesn't mean anything unless I'm talking about one of the vectors. It is the velocities squared, which should make sense. Speed comes from velocity. So I'll square the x component of velocity, add the square of the y component of velocity, and I'll have a formula that'll find me the speed at any given time. And now I have to find if the derivative of that is positive or negative at t equals 1. I'm going to go ahead and just expand everything out. I think it's just going to make the problem a little bit easier. We should end up with 4 minus 8t plus 4t squared plus 1. Yeah. Which I can then just make 4t squared minus 8t plus 5. Cool. Okay. So the derivative of that evaluated at x equals 1, t equals 1. Chain rule, square root. Chain rule says derivative of the inside, so 8t plus 8 over 2 square root 4t squared plus 8t plus 5. I think I made a plus and negative above, didn't I? Fix that up. And that is still being evaluated at t equals 1. Your choice on how you want to show this, I think it should be pretty obvious that if I plug 1 into that numerator, 8 plus 8 is 16, which is positive. This should always, if the number worked in the function itself, it needs to work in the derivative if we're working with these square roots. Like there'd never be a way where you would come up with something where it wouldn't work. But we ended up with 4 plus 5 minus 8. It's actually not a hard one to evaluate. 9 minus 8. Maybe I set it up this way. So that's going to give you 1. This gave you some number that it wasn't easy to take a square root of. As long as it's positive, this denominator works and has to be positive, right? So I could just put greater than or equal to 1 here, but since it's actually going to come out nice, I'm going to actually evaluate it. So I get 16 over 2 square root of 1, which last time I checked is 8. So the particle is speeding up because v is greater than 0. Or sorry, no, the derivative is greater than 0. Let's say v is increasing. Speed is increasing. There we go. And your work backs up that statement. Speed is a function. If you take a function's derivative, it'll tell you whether that thing is increasing or decreasing. If speed is increasing, that's another way of saying that the particle is speeding up. Right? Shoot.
So you know that it's increasing because it's positive?
Yep. Yeah, the derivative of something. If the derivative of something is positive, it's increasing. And if the derivative of something is negative, it's decreasing. Yep. So going all the way back to B11, you could say at time t equals 1, the rate that the particle is traveling at is increasing at a rate of. So yeah, that's why it's increasing. Questions on that one? Yep. And last but not least, example 3. Yeah. This last one is the EVT question. The position of a particle is given by another function, 3 sine t, 4t over pi minus 1, but squared, which I swear there's a reason why we're dividing by pi there. For 0 between t and pi, find the furthest the particle will be to the left, to the right, up, and down. Identify the t value and the coordinate for each, because I want 45 answers to one question. So this actually is really 2 separate questions. Left and right focus solely on the x component. Up and down focus solely on the y component. So we'll do left and right, and we'll just look at the x component. So we'll do that first. Left, right. v prime v of t equals s prime of t. To be, without question, writing that down because it's usually a point. And that is going to give me 3 cosine t. And 4t over pi minus 1, but squared, the derivative of that. Start with 4 over pi. Yep. Times 2 times 4t over pi minus 1, but squared. But to the first power. Drop the power down by 1. I believe when I made this problem yesterday that 4 pi over there was designed to not make our lives more difficult. We'll see if that's the case. I think I was thinking in terms of x's when I did that. All right. So let's start with left and right. I think this is the part where that's going to help us out. We need to know when 3 cosine t is going to be positive or negative. So when is 3 cosine t equal to 0? When is cosine of t equal to 0? Yep. But we are only in between 0 and pi, right? Yep. All right. So t is pi over 2. And then between 0 and pi over 2, and then pi, is cosine positive or negative to start out with? Positive first, right? The cosine of 0 is 1. Cosine starts at 1 and goes down, and then it drops into the negatives. So this is a plus minus. I guess we didn't really need to know that because this is an EVT problem. And really all we need to do is make a chart of t and Vx of t. So I'm going to focus solely on the x component of velocity, but I don't want velocity. I want xp of t because I want to know when it's furthest to the left or right. I needed to find the zeros of its derivative, that where it's velocity, but I actually need to know when it's the furthest to the left or the right. And the 3 places I have to check are 0, pi over 2, and pi. Going back to my position, at time t equals 1, it has an x component of the position of 3 sine of 0, which is 0. At pi over 2, 3 sine of pi over 2. What's sine of pi over 2? 1, so 3. And then in the last one, the sine of pi is 0. So on that interval, the furthest to the left that it'll be is 0, and the furthest to the right it will be is 3. Does that make sense? And that's completely independent of where it is vertically. We don't care about where it is vertically. Of course, the question did say, give me the coordinates, so we'll have to list that in our answer, but we should be good there. So let's see what we got. So furthest left at t equals 0 and t equals pi. And the point for t equals 0 is 0, comma, 4 times 0 divided by pi minus 1 squared. Plugging 0 into that gives me 1, right? Cool. 4t over pi times 0, t is 0. That whole thing is 0. Okay. Now, supposedly I made this easy by putting all these pi's in here. Let's put t equals pi into that. I get 4 pi divided by pi. Oh, okay. I like it. 4 pi over pi minus 1. So 4 times 3 squared, 9? Yeah. You're right. And then it's furthest to the right. At t equals pi over 2. And that is going to be 3 sine, we already know the x coordinate's going to be 3. We just need to figure out the y coordinate. 4 times pi over 2, but then divided by pi. Pi's cancel. 4 divided by 2 is 2. 2 minus 1, but squared is 1. Clock watching. 4 times pi over 2 is 2 pi. 2 pi over pi is 2. 2 minus 1 is 1. 1 squared. We're back up here. 1 squared is 1. Okay. I think we're almost out of time, which is probably better because this is probably a mess as to what makes this 0. I guess it would be pi over 4. So you would have to do all of this for 0, pi, and pi over 4. That's actually not too bad, but we are out of time to do it. Because we already have 0 and pi done. We know that would be 9 and 1. It's just a matter of figuring out, oh, and this would be 0 as well. Yeah. Actually, it wouldn't be too bad, but we get to skip it. That's good. Yeah. That's it. Yeah. The 0 would be 0 for both. That's interesting. Yeah. The 0 of the derivative would also give us 0 in our function because we went from squared to that. Yeah. Biggest number would be up. Smallest number would be down. Yeah, so that's enough to do that. So study for a quiz, do a review, do this. Maybe skip a night of sleep or something. I don't know. You'll figure it out. You guys are good. Or just don't do it, right? Yeah. We'll talk next week about when we want to do our D test. But yeah.